Quadratic formula. When it comes to quadratics, we know how to solve by factoring and how to solve by using the square root property. But what if the problem cannot be factored? What if the problem cannot be solved using the square root property? What do we do? Well, it turns out you can solve any quadratic equation of the form ax squared plus bx plus c equals 0 by using what's known as the quadratic formula. Here is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Take a moment to write that down. Example 1. Solve using the quadratic formula. For a, we have 2x squared plus 9x plus 10 equals 0. Now, according to the directions, we must use the quadratic formula. So here it is in the upper right-hand corner of the screen. Alright, so the first thing we have to do is we have to check the form. Is this written in the correct order? Meaning, first, does it equal 0? Yes. Second, is it in the correct descending order? Yes. Since it is in the correct order, now we are ready to identify the a, b, and c. A is the coefficient or the number in front of x squared, which is the value 2. B is the value in front of the middle term, or in front of x, which in this case is 9. And C is the constant or the plain number, which in this case is 10. So now that we've identified the A, B, and C values, let's see how to use the quadratic formula. So since we are going to substitute these values into the formula, we know that every time you plug in a value, you must use what? Parentheses. So get it prepared with all the parentheses. Now let's carefully plug in the values. The formula says x equals negative b, where our b value is 9, plus or minus the square root of b squared, or 9 squared, minus 4 times a, which is 2, times c, which is 10, all over 2a, but a is 2. So notice we've plugged all the values in appropriately. Now it's time to carefully simplify this bit by bit. So the first thing is the negative b, the out front part. Notice we can read that as the opposite of 9. What is the opposite of 9? Well, it's negative 9. Now we start to simplify under the radical. The first part you see is the b squared, or in this case 9 squared. And we know 9 squared is 9 times 9, or 81. Still under the radical, we have the 2 times the 10. We know 2 times 10 is 20. And in the denominator, 2 times 2, well, that's 4. So we have simplified a lot of parts, but there's still some to focus under the radical. The part that we have to deal with is the multiplication. So, under the radical, we have a negative 4 times a positive 20, which we know gives us negative 80. But we're not done yet. So under the radical, we have the subtraction of 81 minus 80, which we know gives us 1. So we have simplified all parts, but notice we still have a radical, the square root of 1. Well, we should know the square root of 1 is actually equal to 1. So now what we notice is we still have that plus or minus. So we need to look at these individually. Looking at the plus version, we read that as negative 9 plus 1 all over 4, and negative 9 plus 1 can be combined to give us negative 8 over 4, and since that fraction can reduce, we find x equals negative 2. Now let's look at the minus version. This would give us negative 9 minus 1 over 4. Well, negative 9 minus 1 combines to give us negative 10. Now, although negative 10 divided by 4 does not give you a whole number, the fraction itself can reduce to negative 5 over 2. And so these would be your solutions. For b, we have x squared minus 6x plus 2 equals 0. So first step is we check the form. Does it equal 0? Yes. Is it in the correct order? Yes, which means we can now identify our a, b, and c values. A is the value in front of x squared, which we find to be 1. B is the value in front of x, which we find to be not 6, but negative 6. Make sure you do pay attention to the signs. And your c value is the constant or the plain number, which in this case is 2. Now that we've identified all the values, we're ready to plug them into the quadratic formula. Remember, you must use parentheses. So take a moment now to plug in your values. Okay, hopefully for your quadratic formula, you found a negative 6 plugged in first, then a negative 6, a 1, a 2, and a 1. Alright, so now that all the values are plugged in, let's simplify it bit by bit. In front, we read that as the opposite of negative 6, and we know the opposite of negative 6 is a positive 6. Next, we have negative 6 squared, which means negative 6 times negative 6, which of course gives us positive 36. And then still under the radical, 1 times 2 is 2. In the denominator, 2 times 1 is 2. So now we have operations happening under the radical. You want to simplify that first. And according to order of operations, you must deal with the multiplication before the subtraction. So 4 times 2, and actually that is a negative 4 times 2, which gives us negative 8. But we still need to simplify under the radical. We still need to combine what's under the radical, and notice 36 minus 8 we know is 28. Now since we still have the radical, we do need to take the time to factor and if possible pull out any sets. So we know 28 is actually made up of 2 times 2 times 7. Now we do have a set of 2's, so the 2's can come out, and it comes out and is immediately in front of the radical. So we now have x equals 6 plus or minus 2 square root 7 all over 2. From here, since we have that plus or minus sign, we do need to take the time to separate. So looking at the plus version, we have x equals 6 plus 2 square root 7 all over 2. Now notice, the coefficients in the numerator are all divisible by the denominator. Whenever I mean coefficients, I mean the leading term of 6 and the number in front of the radical. So since the 6 and the 2 are both divisible by 2, this can reduce. And it reduces to x equals 3 plus square root 7. Now let's look at the minus version. X equals 6 minus 2 square root 7 all over 2. And again, because the coefficients in the numerator are all divisible by the denominator, this can also reduce to x equals 3 minus square root 7. And these would be your solutions. C, x times x plus 6 equals 2. So we need to check the form. This doesn't quite look right. So what is your instinct telling you to do? Well, hopefully your instinct is telling you to distribute the x. And so x times x is x squared, x times 6 is 6x, and then equals 2. So it looks better. We now officially know this is a quadratic because we see x squared. But is it in the correct form yet? No. Remember, your quadratic must equal what value? 0. And ours does not. So we need to get rid of the 2 by subtracting 2 on both sides. We now have x squared plus 6x minus 2 equals 0. Now our equation equals 0 and it's in the correct order, so now we are ready to identify our a, b, and c. Our a value would be 1. Our b value would be 6. Our c value would be -2. Alright, now that we've identified the values, we carefully plug them in. Our b value is 6. B value is 6. A is 1. C is -2. A value is 1. So we have all the values plugged into the quadratic formula. Now we carefully simplify it. In front, we read that as the opposite of 6, and the opposite of 6 would be -6. 6 squared is 36, and 1 times -2 is -2. And in the denominator, 2 times 1 is 2. Now we still have operations happening under the radical. Again, according to order of operations, we must do the multiplication before the subtraction. And so -4 times a -2 gives us a +8. And again, we still have operations under the radical, so let's look at that next. Under the radical, we have 36 plus 8. That combines and gives us 44. So we've simplified everything under the radical. Now we need to try to factor the radical. If you factor the radical, you should get 4 and 11, but 4 is really made up of 2 times 2 times 11. So it simplifies, because we had a set of 2's, it simplifies to 2 radical 11. From here, because we have the plus or minus sign, we do want to separate. The plus version would be x equals -6 plus 2 square root 11 all over 2. Now notice the coefficients in the numerator are all divisible by the denominator. So this can reduce. It reduces to x equals -3 plus square root 11. Now let's look at the subtraction. This would give us x equals -6 minus 2 square root 11 all over 2. And again, because the coefficients in the numerator are all divisible by the denominator, this can reduce to x equals -3 minus square root 11, and those would be your solutions. X squared minus 10 equals 3x. This is your try it problem. Let's see how you did. First, you should have checked the form. Notice it does not equal 0, so we need to subtract the 3x on both sides. From here, it does equal 0, but notice it's not in the correct order. You will need to rearrange your terms. It should be x squared minus 3x minus 10 equals 0. From here, now we can identify our a, b, and c values. A should have been 1, b should have been -3, c should have been -10. From here, you plug them into the quadratic formula as shown on the screen. We carefully simplify each piece. In front, the opposite of -3 should have given you +3. -3 squared is 9. 1 times -10 is a -10. The denominator would be 2. from here, under the radical, notice you have a negative 10 times a negative 4, which does give you a positive 40. Under the radical, 9 plus 40 would give you 49. Now the radical of square root 49, we know that is actually equal to the value of 7, because there would have been a set of 7s. From here you have your plus or minus signs. The plus version would give you x equals 3 plus 7 all over 2. 3 plus 7 is 10. 10 divided by 2 is 5. The minus version would have been 3 minus 7 all over 2, which gives you negative 4 over 2, which does reduce to negative 2. And so your two solutions should have been 5 and negative 2. D. 1/6 x squared minus 1/2 x minus 1 equals 0. What do you notice? Fractions. And it's going to be okay. Now, we've talked about fractions before. We know when we have an equation with fractions, the first thing is we need them all speaking the same language, meaning they all need the same common denominator. So let's identify the LCD. What is the least common denominator? Hopefully you said 6. So we need to rewrite each and every term with a denominator of 6. Notice that means the left side of the equation and the right side of the equation. On the left side, looking at our first term of 1/6 x squared, we want it to have a denominator of 6. It currently does. So what would we need to multiply by to make it have a denominator of 6? Well, in this case, because it does already have a 6, you do not have to multiply it by a value, or you could multiply it by 1 over 1. The second term has a denominator of 2, but I need it to be a 6, so what must we multiply by? 3 over 3. The third term is a 1. Notice it does not even have a denominator, so how do you make 1 into a fraction? Well, you simply place it over 1. So I see my denominator is 1, but I need it to have a denominator of 6, so what must we multiply by? 6 over 6. Now on the right side of the equation I have 0, which is not written as a fraction. How do we force it into a fraction? Well, you simply place it over 1. Now it has a denominator of 1, but I need that denominator to be 6, so we must multiply by 6 over 6. Now that everything is multiplied by its translator, now let's see what do our new fractions look like. Your first term remains a 1/6 x squared. Your second term now becomes 3 over 6 x. Your constant now is 6 over 6, and it should all equal 0 over 6. Now on the left side of the equation, notice all three fractions have a denominator of 6, which means I can now combine it all together as a single fraction, which means it's now going to look like x squared minus 3x minus 6 all over 6 equals 0 over 6. Now, why did we do all of this? The goal is we are going to wipe out the fractions. We can multiply the left side of the equation by a number as long as we do it to the right side. Now in this case, if our denominator of 6, the only way to get rid of it is to multiply by 6. But we have to be fair. What you do to one side, you must do to the other side. And the reason we do this is because if you're multiplying by 6 and you have a 6 in the denominator, they do reduce to a value of 1. Same is true on the right side. And because they reduce to a value of 1, your new equation is x squared minus 3x minus 6 equals 0. Now check your form. Does it equal 0? Yes. Is it in the correct order? Yes. Now we can identify our A, B, and C. Your A value is 1. Your B value is -3. Your C value is -6. Now we're ready to plug this into the quadratic formula. Now we are ready to plug the values into the quadratic formula. Take a moment now to substitute these values in. Okay, let's see how you did on your values. Now we're ready to simplify. In front we see the opposite of -3 is +3. -3 squared is a +9. 1 times -6 is -6, and 2 times 1 is 2. Now under the radical we need to take care of the multiplication. -4 times -6 is a +24. Now still looking under the radical, 9 plus 24 can combine to give us 33. Now notice we still have the radical, but if you factor 33, notice you only get 3 and 11, and there's no sets. So the radical cannot be simplified, so now we focus on the plus and minus. The plus version gives us x equals 3 plus square root 33 over 2. Notice this case, the coefficients in the numerator are not divisible by the denominator. Our first coefficient is 3. Our second coefficient is a 1 because there's an imaginary 1 in front of the radical. Neither the 3 or the 1 are divisible by 2, so this cannot reduce. Now let's look at the minus version. This would give us x equals 3 minus square root of 33 all over 2, and that would be your solution. Now there is another way to write this, and the other option would be to write it as x equals 3 over 2 plus square root of 33 over 2, and x equals 3 over 2 minus square root of 33 over 2. These are the same values, just different ways to write it. There is no preference.